Okay, so if we're trying to evaluate tangent of 75, we have this sum identity for tangent. That tangent of sum a plus b can be rewritten as tangent a plus tangent b over 1 minus tangent a times tangent b. So it gets kind of bigger with the formula, but at least it's a way of doing it without, using a calculator. In theory, we could use those values that we get from like, a unit circle chart, use those values of sine and cosine that we already know. So the big thing we want to start off by doing is breaking tangent of 75 up into degrees that we know and understand a little bit better. So if you do 45 plus 30, those add up to 75. And now we have an A and we have a B that we can use. So we're going to go ahead and plug those into our formula. So top part of the formula is tangent of 45 plus tangent of B, our B in this case is 30. Let's divide by 1 minus tangent 45 tangent 30. So if you have like those unit circle charts and it just tells you what sine and cosine are, because cosine's the x-coordinate, sine's the y-coordinate, you might have trouble with tangent. But just keep in mind that tangent, like tangent of 45, you can put that in terms of sine and cosine because tangent is sine over cosine, right? Because sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse. Oops, I was saying cosine, so I think I wrote an A. So opposite over hypotenuse divide by adjacent over hypotenuse gets you opposite over adjacent, which is the definition of tangent. So sine of 45 is square root of 2 over 2. Cosine of 45 is square root of 2 over 2. So tangent of 45 must equal 1 because it's something divided by itself. And now we got this tangent 30. So again, we could put tangent 30 in terms of sine and cosine. Tangent 30 equals sine of 30. Oops. Over cosine 30. And so again, this would if you have trouble doing this without a calculator, that would be another place where you'll want to check out like videos or things on doing trig functions without calculators. But sine of 30, let's see, I usually draw these reference triangles where what's opposite of 30 is always 1/2, and then the hypotenuse is 1. And then if you fill out the whole triangle, this would be 60, and this would be square root of 3 over 2. So opposite over hypotenuse would be 1/2. Sine of 30 is 1/2. And then cosine of 30, using that same triangle, adjacent over hypotenuse. Cosine 30 is square root of 3 over 2. Okay, but we can simplify that even further because if you divide two fractions, I'm just rewriting this. Let me move this out of the way. Where's my tool? Get rid of that. I'm just rewriting that fraction because if you have one fraction divided by another, same thing as saying 1/2 divided by square root of 3 over 2. And if you divide two fractions, you can solve by flipping and multiplying, okay? So 1/2 times 2 over square root of 3, the 2's cross cancel, it leaves you with 1 over square root of 3. But then we usually don't like to have square roots in the denominator, so multiply the top and the bottom by square root of 3. Okay, because that's multiplying by 1 effectively. So square root of 3 over 3, because square root of 3 times square root of 3 makes 3. So we just found out tangent 30 is square root of 3 over 3. And so just copying everything else down, we got 1 minus tangent 45 we found out was 1, and then tangent 30 we just found out was square root of 3 over 3. And so to simplify further, let's change those 1's to have common denominators. Here's the top part of the fraction. And then the bottom part of the fraction, we got 3 over 3 subtracted by square root of 3 over 3. The rest of this is just fraction stuff, right? Running out of room here, but got common denominators, so this is 3 3 plus the square root of 3 over 3 up top. Divide by 3 minus the square root of 3 over 3 on bottom. And then to keep simplifying, let's rewrite that using division instead of like drawing that line for division. I gotta move it all the way back up here because I'm running out of so much room. So when we divide, we can flip and multiply. So let's change that second fraction. So that's now multiplication. We're going to flip it. It's now 3 over, and see I'm changing it to multiplication. 3 over 3 minus square root of 3. Now these 3's cross cancel. So I got 3 plus the square root of 3 over 3 minus the square root of 3. So depending on your software, like if it's Alex, it might be okay with this being your final answer. It might even been okay with plugging this last one in that we had back here. But if they wanted to get rid of the radical, let me see if we could do that. You could even get rid of the radical in the bottom of this fraction because you could multiply the top and the bottom by kind of like the conjugate, the opposite sign. Okay, because if you multiply this times this, off to the side, you got to do 3 minus square root of 3 times 3 plus square root of 3. Multiply those two binomials, get 9 plus 3 square roots of 3 minus 3 square roots of 3. So the middle terms cancel, minus 3. So you get 6 on bottom. Let me just double check that. I did that fast. 9. That's 3 square roots of 3 minus square root. Let's cancel out. So minus 3. So that's 6 on bottom. And up top, when you multiply this times this, you're going to get 9 plus 6 square roots of 3 plus 3. So that simplifies to be 12 plus 6 square roots of 3 over 6. But that could be simplified even further because look at the top, you can factor out a 6. Man, the tangent ones, there's a lot of different steps for simplifying. It's really just a huge algebra problem, not a super amount of trig. Just at the beginning there. There's my final answer. Okay, but I think Alex would accept like an answer back here, back at this step. You could try typing that in, but if not, you have to do all those steps to keep simplifying. But this is our final simplified answer.